Among its greatest achievements, the Hubble Space Telescope has been able to track the large-scale motions of the universe. Take an event close to home. Astronomers have long known that the Andromeda Galaxy, currently 2.5 million light-years away, is moving toward our Milky Way. A team of astronomers used the Hubble Space Telescope to find out how fast the two galaxies are moving and whether there will be a head-on collision. They tracked the motion of stars in Andromeda, then projected their movement into the future. Based on these findings, they showed the course of events over the next 8 billion years as the galaxies move closer, then collide, and gradually merge into a new, larger galaxy. If you could wait a few billion years, our night sky would change dramatically. As Andromeda approaches, it will loom large in the sky. Later, when the galaxies begin to merge, they will twist and distort under the pull of their mutual gravity. In time, the new combined galaxy will become an immense ball of stars, what's known as an elliptical galaxy. Even though these two galaxies each have hundreds of billions of stars in them, the stars are all relatively far apart. The chance of any two colliding is extremely small. Our Sun, born in the Milky Way almost 5 billion years ago, will follow a new path as it orbits a whole new galaxy. In the universe according to Hubble, galaxies all across the cosmos are circling each other, merging, and moving into ever larger and denser groupings. Using Hubble to survey patterns of galaxies, scientists have been able to map a mysterious substance that envelops galaxies and clusters of galaxies. This so-called dark matter adds to the gravity of these structures and has been driving their collapse over time. Because of the arrangement of galaxies, astronomers have long known that dark matter stretches out across the cosmos in a vast web-like structure. Actually observing this web has been difficult. Now, a team of scientists has used Hubble to make detailed observations of a dark matter filament, measuring its length, shape, and density. Theories say galaxy clusters form where filaments of the cosmic web meet, so the team focused Hubble on one such cluster with a stream of galaxies moving into it along several filaments. The astronomers used data from several ground telescopes to measure distances to the galaxies within the filament mapped by Hubble and to trace their motions. In so doing, they made the first ever three-dimensional reconstruction of a filament. It extends across at least 60 million light-years of space. From our perspective, we see it gently curving towards us, then continuing almost along our line of sight before it plunges into the back of the galaxy cluster. Observing and reconstructing the cosmic web can tell us how the universe has evolved to date. Scientists wanted to know how it's evolving on an even grander scale. If dark matter dominates the cosmos, will its gravity be enough to cause the universe itself to crash together in a heap at some point in the distant future? To find out, They searched for a type of exploding star that's visible across the cosmos. It is the product of a small burned-out star called a white dwarf that orbits a larger star. The smaller star pulls matter from its neighbor, thereby gradually increasing its mass. Finally, when it reaches a critical mass, it undergoes a thermonuclear explosion. These so-called Type 1a explosions are thought to all have the same intrinsic brightness. How bright they appear to us is a measure of how far away they are. What the scientists found is that the most distant of the explosions were much fainter than they expected. They deduced from this data that the space between Earth and those distant explosions had been expanding faster and faster. Scientists theorized that another unknown force, dark energy, is actually pushing the universe apart at an accelerating rate. This means that the universe will not collapse in a heap. Rather, it will keep on expanding forever, until all matter and energy eventually dissipate to nothingness. In our time, the light of the universe continues to rain down on Earth in torrents, a measure of the energy emitted in a constant process of creation and destruction. Hubble has led a broad effort to capture this light in telescopes stationed both on mountaintops and in space. Through their lenses, we have seen a universe that is evolving on all time scales, from the very short to the very long. In its own brief time in space, Hubble has revolutionized the science of astronomy, while inspiring untold legions of stargazers.